Hi folks, we're going to take a look at number 7 from the October 19th homework sheet. Okay, so here we have an exponential equation, and first thing I notice is I've got a base of 2 and a base of 4 here, which makes me think of writing both sides to the same base. The issue here is this 3 in front. Okay, it's not like I can combine this with either of these two powers. So this is where that idea falls apart. So I'm going to go back to sort of our next step, was try to work with logarithms. Okay, now the reason why I don't mind working with logarithms here, and I'm going to take log base 10 of both sides. Okay, so log of 3 times 2 to the x. Okay, and log of 4 to the x plus 1 is that I'm now taking the logarithm of a product. So what I can do is I can separate this out using the first logarithm law and write it as log of 3 plus log of 2 to the x. Okay. And now what I'm going to do is, what we've done in some of these problems here is use the ski-slope rule to bring down the exponent. In fact, I can even do it right away here on the other side, is bring down the exponent of x plus 1. Okay. And now when I do the same thing on the other side, so log 3 plus x times log 2. Okay, and here I'll do the distribution right away. So I've got log 4 times x. Okay, so see how I use the brackets here to make sure I don't think of this as log of 4x. It's log of 4, that number, and that's the coefficient of x. Okay, plus again log 4. Okay, and so now we end up with a linear equation which we can just solve by opposite operations. So let me start by bringing all the x all the expressions with an x to one side of the equation. So here, if I subtract this, so I'm going to start skipping some steps from what I did before. So when I bring this to the other side, this is going to be minus log 4 of x, and so I'm going to combine the two coefficients of x. So this is going to end up being log 2, okay, from that term, minus log 4 from the term that I'm bringing over from the other side, and all that times x. And then on the other side of the equation, I'm going to have log 4, and then of course the log 3 is going to be brought over, so minus log 3. Okay, and then the final step is just to divide that coefficient. So x is equal to log of 4 minus log of 3 over log of 2 minus log of 4. Okay, and I'm actually fine if you leave your answer like this, but we can simplify this a little, because here we have the difference of two logarithms, another difference of two logarithms, so I can use my second exponent law on each of these to simplify this a bit. So this would become log of, here would become a division, 4 over 3, okay, and this would become log of 2 over 4, which would just be 1/2. Okay, so both of these are acceptable as solutions. Okay, so just to recap here, it was a good idea to think about trying to write everything in terms of the same base. Okay, normally that's what we do when we have base 2 and base 4, but because we had this extra factor of 3, that wasn't going to be as helpful as it might have been in the past. So the idea is to take the logarithm of both sides, because not only does that allow me to eventually bring this exponent out of, this variable out of the exponent. Okay, the first logarithm law allows me to separate out this product into